Welcome to this channel. Today we shall be going through subnetting and all you need to know about subnets. Now we shall try to define what subnetting is, how to create a subnet, how to find the host and network ID. We shall need to know what a CIDR value is, how to find the subnet masks of an IP address, and all questions associated with subnetting. Now, an IP address basically is what we call the Internet Protocol. That stands for Internet Protocol. It's an address or a numerical label, such as what we see right here, that is assigned to a device connected to a computer network. Now, you may connect to a phone, you may connect to a laptop, you may connect to whichever device you have. So all those devices will have that unique numerical label that are assigned to them. Now, IP addresses basically serve two main functions. They act as they are used basically for network identification and also location addressing. So IP addresses are basically of two forms. We have the IP version 4, which is a 32-bit addressing system, and the IP version 6, which is a 128-bit addressing system. Now, we shall understand this in the next video as we try to do the process of subnetting. Now, a CRD value basically stands for the classless interdomain routing. This value basically gives us the total number of network bits in a subnet. Okay, now assuming you have a class A network like this, a class A network usually has a default CRD value of /8. This means it has 8 bits reserved for the network bit, and the remaining 24 bits are host bits. Now, with a class B, it has a CIDR value of /16, the default, meaning that it has 16 bits reserved for the network and 16 bits reserved for the host. With a class C network, it has a default CIDR value of /24, and so it has 24 bits reserved for the network and 8 bits reserved for the host. Now, these classes we're talking about here are basically applicable in the IP version 4, and that's why we are mentioning 24 bits, 32 bits, all the things are ending around that, because we're talking about the IP version 4 network. Now, a class N network of the IP version 4 has a default subnet mask of 255.0.0.0. Class B has a default subnet mask of 255.255.0.0. Class C has a default subnet mask of 255.255.255.0. Now, these networks here have some ranges. We don't just know them just like that. They always have ranges. For example, a class N network ranges between 1 to 126. That's the range for a class A network. And then a class B network ranges from 128, what am I writing? 128 up to 191. And a class C network ranges from 192 up to 223. And it goes on and on and on, because we have basically 5 classes of the IP version 4 network. So let's go to subnetting. And the process of subnetting involves dividing or breaking up a network, a larger network, into multiple small networks. For example, if you're given an IP address like this one, this network here can be divided to create other smaller networks from that given IP address there. So Subnetting will give us the privilege of having those multiple networks assigned to different devices from one given IP address. So for example, if you have an IP address like this one here, 192.168.10.0/24, this one has a default subnet mask of 255.255.255.0. And this network here is basically a class C network because it ranges between 192 to 223. So this one here, this 192, falling within that range of class falling within that range makes it a class C network. Usually by looking at the first digit of your IP address, you can determine the class of that given IP address. So if you look at this other one down here, 192.168.10.0/25, this one also is a class C network. It has a default subnet mask of 255.255.255.0. However, since this is a /25, meaning it has a CIDR value of /25, it means there is one bit that has been borrowed from the host part to make it 25. So which means we have a total number of 25 network bits in this given network. And so if you to list them down, for example, write down all these network bits, 24 of them will bring you up, 24 will bring you up to here, which would fall within the third octet. So now the 25 would mean we shall borrow one from this side, from the host bit, to give us the 25 network bits. And so that would mean the remaining would be the host bits. So because we borrowed one here, eventually we end up having a new subnet mask here, which will be 255.255.128 because of this one borrowed bit from the host part. We shall understand how this comes to be as we enter the other section. So let's wait and we'll see how the things work about. Thank you. Okay, let's continue from where we stopped from. Basically, we're going to see how we can create a subnet. Now, a subnet basically consists of roughly three major parts. We have the network ID. Now, this is always the first address given to a network. Now, we also have what we call the broadcast ID. Now, this usually is the last address of our given network. Then we have the part which we call the subnet mask. Now, this is the bit that is used to identify the subnet of an IP address. Now, all the things may not make sense now, but as we give our first example, we shall see how they relate. Now, I have an example of an IP address here, 192.168.5.0/24. Now, this is a class C network because we saw that a class C network ranges between 192 to 223. So this network here, being a class C network, has a default subnet mask of 255.255.255.0. That is a default subnet mask for this class C network. So, assume you have another network like this one, 192.168.5.0, but we have a /25. This network here would have a default subnet mask being a class C network of 255.255.255.0. However, because of this /25 here, it means we have 25 network bits in this given network. So, what does this mean? This means since this given network here is an IP version 4 network, it means it has 4 octets, which octets total to 32 bits. And so because of that, each octet has 8 bits. So 8 times 4 would give us our 32 bits. So /25 would mean you have 1, 2, 3, 4, 5, 6, 7, 8 for the first octet. 1, 2, 3, 4, 5, 6, 7, 8 for the second octet. 1, 2, 3, 4, 5, 6, 7, 8 for the third octet. Now these, when you add them, already have 24 bits. So the 25th bit implies we're going to borrow it from the host part, meaning we shall have 25, 26, 27, 28, 29, 30, 31, 32. So now we have borrowed 1 bit from the host. So meaning that we have a total of 25 bits. These are network bits. So since we've borrowed 1 from this side, from the 4th octet, it means we're going to have a new subnet mask of 255.255.255.128. Now how do we get this 128? When we bring this last octet here, down here, that last octet is 1, 0, 0, 0, those are 4, 5, 6, 7, 8. This number here is in binary. And so, usually when we are to convert this to decimal, this would be to power 0, to power 1, to power 2, 3, 4, 5, 6, and 7. So writing this in the decimal form would be 1 times 2, which is binary 2, which is base 2, which is binary, times 2 to power 7, plus 0 times 2 to power 7, plus 0 times 2 to power 0. So this is to power, this is the first one here is 1 times 2 to power 7, the next one is 0 times 2 to power 7. So you realize that we only have this 1 times 2 to power 7 plus the rest being 0. So when you add up this, we shall remain with 2 to power 7, which is equivalent to 128. So usually we have this table here which we reference. We use it for reference purposes whenever we're handling subnetting. So this 128 that we've gotten here is because of this bit here which is turned on. So since this last bit here is turned on, this is what makes the new subnet mask to be of this value. Okay, so now we're going to try to handle some numbers now as we go on with this this example. Okay, so let's try to subnet these numbers here. We have 192.168.5.0/25. So given this number here, this is a class C network with a default subnet mask of 255.255.255.0. So to get the new subnet mask, we shall have to find the meaning of this /25. So this /25 would mean you have 25 network bits, 1, 2, 3, 4, 5, 6, 7, 8 for the first octet, 1, 2, 3, 4, 5, 6, 7, 8 for the second octet, 1, 2, 3, 4, 5, 6, 7, 8 for the third octet. Those are 24. Then the borrowed bit is 1. 1, 2, 3, 4, 5, 6, 7. So because we borrowed this 1 bit here, this last bit, this one here, using our reference table has 128, 64, 32, 16, 8, 4, 2, and 1. This one, whenever you subnet, you should have it. Okay. So this one here is in the position of 128. So the new subnet mask would be 255.255.128. So that is it. So now we are going to go ahead and break this network into other smaller networks. Oh no. Okay, so how do we break up this network? Number one, at least we have found that the meaning of this /25 implies there's one borrowed bit. So first of all, we shall need to know how many networks can be created. So to determine the number of networks that can be created from this IP address, we use the formula 2 to the power n, where n is a number of borrowed bits. So you realize there's only one bit which has been borrowed from the host part. This side is the network part, this is the host part. So because you borrowed 1, it will be 2 to the power 1, which is equals to 2 networks. This can be maybe network 1 and maybe network 2. That's basically how you can call it. Now, how do we determine the number of hosts in this given? Maybe okay. For now, let's first find the number of IP addresses in this network. In each network, that will be created in each network. To find out the number of IP addresses in each network, we shall also use the formula 2 to the power n, where n is the number of remaining bits. So since we borrowed 1 bit from the last octet has 8 bits, but you borrowed 1, so it means you're remaining with 7 bits. So which means we shall have 2 to the power 7, which is equal to 128 IP addresses in each network. So how about the number of hosts, or maybe what we can call usable IPs? This would be 2 to the power n minus 2, where n is the number of remaining bits. So that will be 2 to the power 7 minus 2, which is the same as 128 minus 2, which will give us 126 IPs in each network. So these 126 IP addresses are the ones we give to our clients. So it means these ones here are the ones which are usable. Now, first of all, we need to take note of something here. The total number of IP addresses in each network is 128, but the total number of usable IP addresses in that network is 126 because of subtracting minus 2. So the minus 2 is because this minus 2 here is because the first network bit is reserved for the network ID. And also the last network, not network bit, but the last network is also reserved, or the last IP address is reserved for the broadcast. So that's the reason we always have this minus 2. So this minus 2 is because the first IP address is reserved for the network ID, and the last IP address is reserved for the broadcast ID. So now that we have this kind of setting here, we have 2 networks. So how will our IP addresses be? This is what we do. You'll say network 1 will have an IP address of 192.168.5.0. So this is the network ID. So to determine the next IP address here that will be usable, all you have to consider is you look at the next IP address from what you have there. So this will be 192.168.5.1 because it will begin from 1, and now beginning from 1 it will go up to 126. So this will be 192.168.5 up to 126, and then to determine the next one here would be 192.168.5.127. So this here becomes our broadcast ID. So the next network will have an ID of 192.168.5.128. Now, if you have the first network ID, the next network ID, all you have to do is to add the first value here, or the first value here, to the number of networks that have to be added on that, the number of IP addresses that have to be added on that network. So if you have here the first network ID as 0, by adding 128, which is the total number of IPs, we shall get the next network ID. So also the next network ID minus 1 should give us the broadcast ID for the previous network. So here our next network would be 168.5.129. From 128 you go to 129. So then the next one will be 168.5 dot. Since this network here is the last network of this given IP address, it means the very last IP address would be 192.168.5.255, because for an IP version 4 network it ranges between 0 and 255. So the last network ID will be 255. So which means when you subtract minus 1, it should give us 254, which becomes our broadcast. This becomes our last IP address, and so this becomes our broadcast ID, and this becomes our network ID. So this is basically what you do when you're subnetting an IP version 4 network. So let's look at the second example. We have 192.168.0/26. So first of all, we'll draw our table, which we shall be using for reference purposes, which is 128, 64, 32, 16, 4, 2, and 1. So this table is very important. So I usually draw it whenever I'm going to do some bit of subnetting. So number 1, we shall find the meaning of /26. This is the same as 1, 2, 3, 4, 5, 6, 7, 8 for the first octet. 1, 2, 3, 4, 5, 6, 7, 8 for the second octet. 1, 2, 3, 4, 5, 6, 7, 8 for the third octet. Those are 24. So now 25, 26, 27, 28, 29, 30, 31, 32. So you realize here we have borrowed 2 bits from the host part. We borrowed 2 bits. Therefore, the new subnet mask for this network here would be 255.255.255, being a class C network first of all, and then because we have borrowed 2 bits, these 2 bits we shall translate them to our table here. So this one here is in this position, and this one here is in this position. So we shall have 128 plus 64, which should give us around 192. So when we add up this becomes our new subnet mask. Okay, so after doing this, after having this, we now go ahead and find the number of networks that can be created. From this, we said we use the formula 2 to the power n, and n is the number of borrowed bits, so which means this will be 2 to the power 7. 2 to the power, you borrowed 2, sorry, you borrowed 2, it will be 2 to the power 2, which is equals to 4 networks. So that will be network 1, network 2, network 3, and network 4. Something like that. So now, the number of IP addresses in this given network would be 2 to the power n, but this time around, the n is equal to the number of remaining bits. So if you have borrowed 2 out of this last octet, you're remaining with the 6. That would be 2 to the power 6. So 2 to the power 6 would give us around 64 network bits. That would be 64 network, IP addresses. So this will be 64 IP addresses in each network. So to find the number of usable IP addresses would be 2 to the power n minus 2, where we shall have 64 minus 2, which should give us 62 IP addresses in each network. These 62 are the usable IP addresses. So remember, we said that we subtract minus 2 because one network bit, which is the first one, is for the network ID, and the last network bit is for the host, for the broadcast ID. So, having found all this, how would we get our network? So maybe we can draw a simple table. Maybe, so this one is the network ID. So you have network 1, network 2, network 3, network 4. So network ID for network 1 would be 192.168.1.0. That's the network ID. And then we'll also have the next network would be, you just add this plus the total number of IP addresses in each and every network, which would be 192.168.1.64. So the next one also would be just a matter of adding this 64 plus the total number of IP addresses, which is .1. This is 128, and then the last one will be 192.168.1.128 plus 64, so that will be 12, which is 192. Okay, so now these are the network IDs for our 4 networks, which can be created with this. Now, we determine the broadcast ID. Broadcast ID. So we said that the broadcast ID is, if you have the second network ID, when you subtract it minus 1, it should give you the broadcast ID for the first network. So which means our broadcast ID would be 192.168.1.64 for this second network, minus 1 will give us 63. So that's the broadcast ID. Then for this other network 2, it would be 192.168.1.128 minus 1 would give us 127. So that's the broadcast ID. So for this other network here, network 3, it will be 192 minus 1, which will be 192.168.1.191. And so the last broadcast ID will be 192.168.1.255. So usable IPs would be what falls within this range. What falls between the network ID and the broadcast ID is what becomes the usable IP addresses for our clients. So which means if you have your 192.168.1, the very first usable IP address will be from 0 you go to 1 would be 1, up to 192.168.1. The very last IP address before you reach the broadcast IP address would be .62. So that's all you have to do here. This is 192.168.1. What falls between this, the next one after 64 is 65, and so the last one will be 192.168.1. What falls between before you reach the broadcast ID of 127 is 126. So this is all how you have to play with this. So these ones are all the same. This is 129 up to the last one here would be 190. The rest are constant. These first three are constant. You just have to copy them. So then this one also, if you have 192 as the network ID, the next one will be 193, and the last one would be 1 less of this broadcast ID would be 254. So by doing this, that's basically how you would do break up your network, and that's basically what we call subnetting. So this is quite very simple. Let's try other examples with a class. One more example with the class C, then we have at least an example in class A or a class B, and then we're done with this section. Okay, let's try out this other number here. This was a class C network. Now, to subnet this one, it will be slightly different from the previous ones, but more or less the same. We'll find out the meaning of this /20 by writing all the network bits in this network. 1, 2, 3, 4, 5, 6, 7, 8. The first octet, 1, 2, 3, 4, 5, 6, 7, 8. Second octet, 1, 2, 3, 4. 16, 17, 18, 19, 20, 21, 22, 23, 24, 25, 26, 27, 28, 29, 30, 31, 32. We'll draw our table, our reference table, 128, 64, 32, 16, 8, 4, 2, and 1. So this table is very vital. So if you realize this number here, this time around, our third octet is having something which is incomplete. These first octets here are having all the ones turned on. This one here has all the zeros turned off, but this one here has some turned on and some turned off. So this would give us a subnet mask, a new subnet mask for this number, being 255 for this one's turned on, 255 for this one's turned on. But now these ones here, we shall count how many are turned on. We have this, and this being turned on. So this should give us some number. I don't know, let me try to add that. That is 128, 64, plus 32, plus 16. This is 10, this is 20. Okay, carry 2, this is 10, this is 14. So this is 240.0. So this is our new subnet mask for this. So now if you realize the number we were doing previously, we basically had almost all these numbers not being affected, and only would change the last values. But it seems now this one here, were borrowed from the 20 ends up in the third octet, and so which means this very octet here would be the one that will be affected with this. So if I'm to draw a simple table here, this number would have something like 192, 168. Okay, let's call this the network ID. Okay, we have the broadcast ID. Okay, So you realize these two are going to be constant. They will remain there. We have this other octet and then this other one. Now, since this octet is going to be affected, we shall have to find the values that fall within this. However, if this last octet, if all of them are turned off, eventually this will be 0. However, if this last octet, if all of them are turned on, meaning they have 1 1 1 1s here, this would have 255. So which means we have a challenge of finding the values that fall within this area here. So how do we find these values? Number one, we shall have to locate this number here, which is 60. We shall have to convert this 60 to binary. So, converting this to binary, all you have to do is go back to your primary level mathematics, divide this by 2, binary meaning base 2, so you divide it by 2, you have 30, remainder 0, you divide this by 2, you have 15, remainder 0, you divide this by 2, you have 7, remainder 1, that is 14, by 2, you have 3, 4, 6, remainder 1, and then by 2, you have 1, remainder 1. So now, when we convert this to binary, we'll write from down, moving upward, which means we're going to have 1, 2, 3, 4, 5, 6. However, our octet always has 8 bits, but these are only 6 bits, so we shall have to add other 2 bits behind with the zeros. We just add those zeros behind to make it an 8-bit octet. So now, the value of 60 we've gotten here, is the value that will give us the value that has to be inserted here. This value we've gotten here is what we shall use to get the values that will enter here. Now, we shall go ahead and map. This /20 with this 60. Our /20 is this value here. This octet here is what we're going to basically concentrate on. So we shall have our 1, 2, 3, 4, 5, 6, 7, 8. Those are 8 for this value for this /20, this octet. But now our 60 also has values 0, 0, 1, 2, 3, 4, 5, 6. So these are 1, 2, 3, 4, 5, 6, 7, 8. Those are 8 of them. So when we map them, here if you learn some truth tables in mathematics, what are those truth tables? So to map this, you try to do it as you do with multiplication. You'd say 1 times 0 would be 0, 1 times 1 would be 0, 1 times 1, 1, 1 times 1, 1, 0 times 1, 0, the rest are 0 zeros. So the result we get from this, which is this value here, we extrapolate what we have here. This 1 is equivalent to the 32. The first one here, the middle one here, because you have this first one is for this 128, you have this 0 here is for this 64, and this one here is for 32. So this is 32 plus this other value here, which would be 16, should give us a total of 48. So this 48 here, which we have gotten after mapping this, is the value for the missing value that we have here. So our network ID is now complete with 192.168.48.0. Now, how do you determine the value that will be the broadcast ID down here? So what we do, we find the magic number. So the magic number, we get our 20 our /20, which is this value here, which is 1, 2, 3, 4, 5, 6, 7, 8. And then the very last value of this /20 here, of this CRD value, being the third octet here, the very last value here is what then our network is being incremented with. So this here, of course, is equivalent with this. It is standing for in this position, so which means we have that last one. This last one here is it means our network is increasing by the value of 16. Now this would do by adding 48 to this 16 would give us the next value for the network, or the next network ID, the next network ID. So since we're finding the broadcast ID, we subtract this value here, which we get from this, minus 1. So this plus this should give us 64. So minus 1 would give us 63. So which means the broadcast ID here will be 192.168.63.255. So to determine the usable IPs, all we have to do is to write this value here, which is 192.168.48.1 being the first value, up to 192.168.63.254. So it should be less by this by 1, but this should be, the first one should be an increment of this by 1. So this is 48.1, which is this, up to 63.254. So these ones here are the IP addresses we give to our client. These are the IP addresses we assign to our client that is within our network. So basically that's the secret of subnetting. So you can try out other numbers at your free time, but this is all you need to know for the start as far as subnetting is concerned. Thanks for watching. Till then, God be with you.